Please kindly welcome Pauline Vos, coming from Amsterdam, to speak to us about how to be a Git rockstar. Pauline?
Hi, everyone. Thanks for coming to watch my talk, or not leaving the room, rather. So I hope you're all ready to get legit. Before we start, I'd like to just quickly introduce myself and what I do. So I'm Pauline. I work at Werkspot, which is a company in Amsterdam. It's like a marketplace for consumers and service professionals. So if you're a homeowner and you need like something done to your kitchen or a room painted or whatever, you go on the platform and we hook you up with a service professional. That's essentially it. But yeah, over to the order of the day. Is this you when trying to work with Git? Because this has been me for a very long time before someone came in and told me a lot of the stuff that I'm about to tell you. So I've spent just hours solving merge conflicts, screwing around with checking out branches, accidentally overriding changes, that sort of stuff. But obviously, the zone that you want to be in as a developer is this one. The one where you're like in your elite hacker zone with your fingers dancing around the keyboard. And so, like I said, someone came into my team and taught me a lot of the stuff that we're going to talk about today. And I was really skeptical because when someone comes in and tells you to change your workflow, it's kind of scary because changes, you have to get used to them. It's going to take time. But I promise you, it's really not going to take that much time to get into it. And when you do, you're going to be like this, I promise. And the basis of basically everything that we're going to talk about today is atomic commits. So who here has ever heard of atomic commits? Okay, about half of the room. Who has never heard of atomic commits? Unsurprisingly, about half of the room. So if you've never heard about atomic commits, it's basically what they sound like. If you look at the word atomic, it's a small thing that you can't split up, basically, and that's what atomic commits are. That's a bit vague and cryptic, so we'll just go through 3 things that I think an atomic commit needs to have to be an atomic commit, if that makes sense. So the first one is the most obvious one. An atomic commit needs to be a single irreducible unit, which means one commit is about one set of changes, one feature or one fix, and one part of the code. So just to take an example, if you look at the commit on the left, you'll see the message is build sign-up feature, refactored mailer class. This commit holds the entire sign-up feature, controller, repositories, entities, templates, etc. And the mailer class needed some refactoring too, I noticed, so I just went in and did that while I was there. So this commit does a whole bunch of things. And then on the right, you see 3 separate commits. You see the bottom one refactors the mailer class, and the next one creates all the persistence stuff. And then the top one finally creates the endpoint and the controller. So the ones on the right all pertain to one thing each, and the one on the left doesn't. Then the second one is that everything works. So that means that all your tests are green, nothing breaks when you run your application, everything's covered in tests, and that's on any commit. So that's not the last commit on your PR, that's all your commits. Nothing breaks on any of the commits. And lastly, every commit is clear and concise, which is to say that the commit message is short. You can see in one glance what it's about. And that already becomes a lot easier when you keep to the first feature of atomic commits. If everything pertains to only one thing, you don't have these messages like did this and that and that. It's one thing. So these 3 things are basically it. And that sounds really simple, and it kind of is, but it's going to help you with a lot of different things. And we're going to go through a few of them, and the first of them is the most important one, I think, and that's keeping your sanity. So take this scenario, you've branched off, someone else is working in parallel to you, they've created a PR, they merge in their changes, and then you need these changes on your branch. So you have 2 options. You can pull all the changes in and create a merge. Who would do that? No one's going to pull in the changes? Who's going to go git pull and then, okay, one tiny hand. Who's going to, some people are lying. I know that for a fact. Okay, and who would rebase? Okay, and everyone else who didn't put up their hand just does nothing. Fair enough. So let's just recap a little bit what the difference is between merge and rebase. So this is the starting situation when you start to merge. So your yellow branch is your base branch. Then you've branched off. You've started doing some changes. You create a few commits. And then eventually, obviously, there's these 3 other commits that are not on your branch that you want on your branch, right? So then you pull that in, and you merge. And what Git does is it takes the delta of the last point in time and just like smooshes them together and creates a new commit. And then it lets you resolve any merge conflicts that you might have and create a new commit out of that, which is simple enough. You know, you solve conflicts once and then simple. But it's not great for history because if you look at what it does, if it just takes all the changes from all these different commits and smooshes them together, it's not going to be about one thing. It's going to be changes from all over the place. So you're not going to be able to, in your commit, say what changed, because all you did was merge, if that makes sense. Like, you can't say, like, oh, merged this bug fix with this, because it's changes from all over the place. So it's not great for your history, and you have to keep doing this every time the base branch updates. Every time you do this, you pollute your history with these merge commits. Then Git Rebase, so same start situation. You have your base branch, and then you have your own branch, and you start making commits. But then rebasing is basically making, basing your branch onto the base branch again, as if you've just checked it out. And under the hood, it kind of looks like this. Git checks every single commit, replays them, checks the delta between those commits, lets you solve the merge conflicts there, and then rewrites your local commits to, it basically rewrites history. So it takes the changes from the commits on your base branch and commit by commit cleans up your history. So your history stays intact, your messages stay intact, and you don't get these weird merge commits that don't really tell you anything. Which is much better for your history, as you can imagine. But then if you don't use atomic commits and you rebase, you get this, which happened to me a lot when I started using Git Rebase, because it was one of those things where someone told me I should start using it because it's better, but didn't tell me why it was better. And I just went, okay, they're saying it's better, so I'm just going to implement this. But then if you don't use atomic commits, what you do is, because there's changes from all over the place on every commit, and on one commit, for instance, you've made a change to a certain piece of the code, and then on this second commit, you're touching the same part of the code. So when you replay that, you have to solve the same conflict over and over and over again. And if you use atomic commits, that never ever happens because it's contained to a particular part of the code. And honestly, the whole having to solve merge conflicts over and over again becomes much worse with rebase if you're not using atomic commits than with merge. So if you're not using atomic commits, just stick with merge, because rebase is the worst, and it's super frustrating. It doubled the time I was spending on merge conflicts. And merge conflicts lead to frustrated developers. I don't know if you've ever heard of a website called Commit Logs from Last Night. It's really good. So it's basically like a feed that crawls public commit messages for random profanity and creates just a feed of angry commit messages. It's pretty good. It's dead now, I think, which is a shame. But yeah, you can check it out if you take a picture of the QR code later. It's worth it. Throughout the talk, there's going to be QR codes, so just like take a photo if you want to go back to whatever I put there. So the next thing that this helps with, if you look at that atomic commits help with, if you look at this, it's funny now, but you wouldn't want it in your history, right? Especially if you're like part of a big company with different teams and new people come in and they see this in your history, or if you're doing an open source project or something. So that brings me to the next thing, and that's history. So the way a lot of people start out using Git is they use it as a save point. So let's say you're typing a Word document or whatever, and you haven't saved in half an hour, and you're thinking like, oh, Word might crash, so I'm going to save. Otherwise, I lose all my stuff. And then you type another half hour, and you save again, you save again, you save again. It's like checkpoints. Same with video games. You make some progress, and you're like, if I die now, I'm going to lose all my progress, so I need to find a save point. So it's like a time-based linear thing. And so it makes sense that a lot of people use Git in the same way, because it feels kind of like a save point as well. But then you end up with situations like this. So if you start at the bottom, there's a, it's pretty close to the bottom. I don't know if everyone can read it, but the first commit there at the bottom is fixed small bug. So there was a bug, and you went to fix it, and you created a commit, and you thought you were finished. But then the second commit, you see that it says fixes the fix, because you accidentally broke something else while trying to fix this bug. So you're like, oh, shit, I have to change this. You create a new commit. OK, you push, you create a PR. Someone requests changes, so then you have to go back and address the comments. OK, addressed comments, because that's all you did. You can't really say anything else about it. And then you keep doing this until you end up with this. And the thing is, if you look at this, there's a few problems with this, and that's, first of all, none of these really capture your application in a stable state. There's one commit that said fix the bug, but it didn't actually fix the bug, so you can't go back and be confident that that bug was fixed, because everything's still broken. So that's one of the things. But then also for context and for your history in general, and knowing what's going on in your history is not great either, because outside of the scope of your PR, this isn't going to make sense to anyone. Like, someone reviewing your PR is going to understand what these commits are about. But once it's merged into master or whatever main branch you're using, and someone looks at these commits, and they see addressed comments, they'll be like, what comments? What part of the code is this touching? And ideally, you want this. This is what you set out to do. You set out to fix the bug. That's why you started working, right? So ideally, all of these changes are in this one commit. But how do you do that if you've already saved? Well, you can overwrite the save points, and this is probably the simplest command that we're going to talk about today, and it's git commit amend. And it basically just takes your stage changes, and then you go git commit -- amend, or -- am for short, and it just takes those stage changes and adds it to the last commit, overrides that commit, and again rewrites history essentially. Under the hood, though, it does mean it essentially Git throws away the old commit and creates a new one and acts like it's the old one still, but that does mean that technically it changes the commit hash. So when you try to push, your origin is going to reject it, because your origin is going to say, like, OK, this doesn't match, so this doesn't belong here. So what you have to do is you have to force push, which sounds scary, but it really isn't. So we'll go back to that later, but trust me, it's fine, usually, if you do it right. So just to quickly demo, again, this is a pretty simple command, but so you see I have 2 commits here. I'm going to make some new changes. And there's my end-stage changes. And then I'm going to add it. And then I'm going to go git commit -- amend. And it gives you the opportunity to, like, change the commit message and everything. It opens a temporary file, so it just opens in your standard text editor, and then you can rewrite the message and write the file, and then it's overwritten your last commit. But then what happens if there's changes that belong to 2 commits ago, or 3 commits ago, or 4 commits ago? You can't use git commit amend, because that only amends your last commit, right? OK, so we mentioned Git Rebase before, and you can do that on other branches, but you can also rebase onto your own branch. So Git Rebase, normal rebase, just replays and does something to all your commits, right? But then interactive rebase does the same, but gives you a bit more control over how you rebase and how Git replays those commits. So you can go git rebase -- interactive for that, or -i for short. And then if you want to do that onto your own branch, you go git rebase -i and then head tilde however many commits you want to go back. And before we demo, we're just going to look at what that looks like. So again, it opens a temporary file in your standard text editor, so in this case is Vim. And you'll see at the top, you'll see the 4 commits, the 4 most recent commits, because I did head tilde 4. And it starts top to bottom, by the way. Bottom are the newest ones in this view. And you'll see they're prefaced by pick. And pick just means basically just replay that commit and don't do anything with it. But there's different commands you can replace that pick with. And you'll see them in the legend. We'll just go through them really quickly. So if you just remove pick and replace pick by any of the commands there, Git will replay that commit, but then also do what you've put as the command. So again, pick is just replay it, do nothing with it, as if you're doing a normal rebase. Then reword opens the commit message, just as you just saw with commit amend, and it gives you the opportunity to rewrite the message. Then edit. This one gives you probably the most flexibility and the most power. It basically just checks out the commit as if it's your head, and then you can do all your changes, you can stage them, you can amend, you can reword, you can do everything basically. And then squash is you take this commit and then smush it into the one before it, and it'll open up a text file to make one commit message for both commits, basically, and it makes one commit out of it. Then fixup does the same, but it's slightly quicker because it doesn't do anything with the message. It just takes the message from the first commit and puts your other commit in there, and then just keeps going. X is pretty interesting because you can run commands there. So let's say you want to make sure that every commit the tests are green, or there's no linting errors or whatever. You can run those commands on every commit, and it'll just fix linting errors for you and that sort of stuff. And then drop is just remove the entire commit. It just, all the changes that you made there are undone, basically. So that's the whole legend. We're not going to demo all of them, but we're going to go look at the edit one, because that's one that you're going to probably be using a lot if you do atomic commits. So you'll see I have some changes there. I'm going to stash them. Then I'm going to go into my interactive rebase, and I'm going to go back 5 commits in this case. So you'll see the 5 commits, and I want to edit the first one and the 4th one. So if you then write that file, it'll check out the first commit. I'm going to apply my stash. So here's my changes back, and then I'm going to stage the changes. And when I do git rebase -- continue, it'll act like git commit amend. It'll just add it to the commit that you've checked out. And then it'll continue to the next thing, like it'll go through the next commits. So it stops again at the 4th because I wanted to edit that one. I'm going to make some changes, stage them, and then git rebase -- continue, and that's all I wanted to do. So then your history is kept clean this way. Everything that was supposed to go in those commits are now in those commits. I've rewritten history, and everything's nice and clean and where it belongs. Another thing atomic commits are really good for is code review. So when I wasn't using atomic commits, I would go to the Files Change tab on GitHub or GitLab. I think it's about the same. And it makes sense because you want to look at the things that have changed. So you see a tab that says Files Changed, and you're like, OK, I'm going to go there. But then you have, in this case, like 30 files in no particular order with no context except for what's in the PR description. So you don't really, it's kind of information overload. And I found myself just reading through everything, not really, like, it didn't really sink in. Like when you're reading a book and you're halfway through the page and you're just like, oh, I zoned out. Now I have to start all over again. So you can imagine that the quality of your reviews are also not great. Plus, it takes a lot longer. It's a lot more frustrating. And if you start using atomic commits, there's something you can change about your review process, namely that you can start reviewing commit by commit, which you can't do if you're using these checkpoint commits, because let's say you start at the first commit, and you see something you don't agree with, and you comment it, you request changes, and then you go second, third, fourth commit, and then on the fourth commit, you see that they've already changed that thing. So it's already outdated. So it kind of like, it gets really frustrating. It doesn't really make much sense. With atomic commits, because everything belongs to one part of the code or one feature, one fix, you know you're looking at the most up-to-date changes and you're commenting on those. So what I do is I just like command tab and open everything in a background tab and just go tab by tab by tab. And what's also really nice is that you now have the commit message for this chunk of changes. So this isn't the best example of commit messages, I have to admit, but we'll get back to that. But you do have this context that belongs to this chunk. So you don't have the entire PR, don't have the entire feature that you're releasing. You're like, literally, I've changed 5 files in this commit, and this is what, and this is why. And so not only does that chunking up make it a little bit more easy to handle for someone reviewing, it also makes it so your reviews have higher quality because you know what you're looking at. So there's a few different standards for commit messages, and it's a good idea to at least have one standard as a team, but preferably as a company as well. And there's all these different standards, like some people might put the issue number, like the issue tracker number, in front of the message so that people can go like, oh, this belongs to this issue tracker. I'm going to check out what the issue was. Or they'll put feature or fix, or so to kind of communicate already what kind of commit that particular commit is. We use this standard, which is just a really simple commit message or subject with no issue tracker stuff. There's a reason for that, like we migrated issue trackers. And if you're putting like issue numbers in your messages and you migrate, then all those issue numbers don't make sense anymore. But there's a few other reasons. But there's some generally accepted rules. There's like a set of rules that I think are pretty good to keep into account. The first one is separate the subject from the body with a blank line. We'll get back to that as to why that's a good idea. By the way, again, there's a QR code there. These rules are from this blog post, and there's a lot more good stuff in that blog post, also more practical tips and tricks that won't be covered in this talk, so it's probably a good idea to go there. Second, you want to limit the subject line to 50 characters, just so you force yourself to make the message concise, and so that people can just read it and at first glance just see what's going on. You want to capitalize the subject line. Again, that just makes it a little bit more readable. Don't end the subject line with a period. This one, I've never fully, like, that's not a hill I'm going to die on if you're putting like a period at the end of the subject line, but I guess it saves a character and it sets a standard, so I don't do it. Use the imperative mood in the subject line. This is a pretty big one, because what a lot of people tend to do is go like fixed, bug, or adds feature, or added. And aside from the fact that you save characters, if you use the imperative mood, which would be fix bug, add feature, create, blah, 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 it's also more of an active voice, so it's more direct. So when you're reading it, it just reads more smoothly. Then wrap the body at 72 characters. Seems really arbitrary, but wrapping it is actually pretty important. I've had teammates not wrap it, and then you go on GitHub, and you literally have to like scroll horizontally for one line, and then go all the way back at the start of the line again, so it's really annoying. And when you have the 72 character line wrapping, it's just like a really nice, neat sort of block of description. And then lastly, and this I think is the most important one, which is why I said the last commit message wasn't a great example, because it didn't do that. But use the body to explain the what and the why versus how. So the subject line I always use for the what, like what did I do? Fix blah, 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 bug. And then blank line, and then in the description I say why I did that, I explain why I did that and how I did that. And that should give you all the context you need to properly review something. So let's take another couple of examples. If you look at the first commit on the left, you'll say, you'll see addresses comments about the test not passing and the class being too bloated. It's very like, it's not about one thing. It spans two lines. It doesn't really read fluently. And yeah, I don't know. If you're gonna put that in a Git log and you're gonna want like a really plain overview of changes, you're not gonna see this and go like, oh, this is what happened there. And then to the right, you'll see that short subject line, the wrapping, and the blank space in between. And then if you git log, ooh, I forgot to take out that dash on the right. I'll get back to that. OK, so if you git log, that's the standard git log on the left, you'll see the subject line and a little description underneath it. And then when you go to git log -- one line with no dash between one and line, just use git autocomplete, you'll get there. You'll see you'll see it's a much faster, just little overview of everything that changed. And yeah, I don't know, I like using that one. And if you go back to the commit on the left there, that's already 2 lines for the subject, so that whole 1-line thing isn't going to work. So just use a really short subject line with a blank space, and then you can get a really nice overview. Now you might think, okay, 50 character limit on the subject line, 72 character line wrapping on the body, that's all nice, but like, am I expected to manually count these characters every time I create a commit message? No, of course not. So if you follow this QR code, it goes to a bash configuration that has a bunch of really handy stuff. I've kind of tweaked it because I don't need all of it. Like he's put like a spell check in there that's kind of annoying. So I've taken that out. I've changed some of the colors, but this will have like git auto completion. It'll show you when your subject is too long. It'll do the line wrapping for you, like it'll jump to the next line. So that's quite nice. Incidentally, the guy that introduced this stuff into our team that I was talking about before, so thanks, Luis Cabucci. Some really quick wins you get from atomic commits, apart from the fact that everything's contained and it's good for your history and all that. Some other quick wins is, well, one of them is cherry picking. So let's say you have that situation from before where you're working on something, then your teammate is working on something in parallel, and you need one of their small sets of changes, but you don't need the entire branch. So you don't want to like bother with rebasing onto their branch and solving all the conflicts that you don't need to solve. You just want to take one set of changes, drop it into yours. That now becomes really easy because all the changes that you need are limited to one commit. Also, there's no other stuff in that commit that you don't need because everything pertains to one fix or feature and one part of the code. So you can just really easily take that, drop that in, and there's usually no conflicts. So that's quite nice. Assuming you're all using atomic commits, assuming your teammate has also been using atomic commits. So let's see how that works. Let's say this is the commit that I want. I'll just go check out my own branch again. So this was the other person's branch. You'll see there's 2 commits there on my own branch. And then I go git cherry -pick and then copy or paste the hash of the commit that I want. And then, oh, I already did git log. And then you'll see that that commit is now in my on my branch. So really easy. Then another thing that becomes really easy is dropping stuff. Because again, you don't have like changes that don't belong to that commit that you. So if there's one particular thing that you want to drop, you can really easily drop that without worrying that you're going to drop other stuff as well. So a really common example that I've come across a lot myself is that, for instance, I'd be working on something and then I noticed that the same class that I'm working on needs some refactoring. So I split those things up. The refactoring I put in one commit, and the actual thing that I'm working on I put in another commit. So if I want to drop either of those, I don't mess with the other ones. Specifically, I think the first time I was like, wow, this is really handy, is when I was like PHP 7 proofing a certain class that I was working on, and then I realized that in a lot of places we were actually passing the wrong argument types. So if I were to like make them strict, it would like we'd get errors all over the place. I was like, okay, I actually have to get rid of those changes. But luckily, I put them in 2 separate commits. So I could just take out that PHP 7 proofing stuff without having to worry about the other stuff. If I put it in 1 commit, I would have to manually go back and manually change all these things while leaving in the other changes and possibly accidentally removing those as well. So now I didn't have to do that. So let's just see how easy dropping is. You'll see I have a few commits there. Let's say I want to drop this one. And then I go into my interactive rebase. You saw drop there in the legend before. It was like a D for drop, but you can also just cut the line. You don't even have to use the D. Just cut the line and it will remove the entire commit. So that's super easy. Next thing, this is kind of like an enigma for a lot of people. They're like, oh, I've heard of Git Bisect, but I'm not sure what it does or why I should use it. And you might wonder why I've put a little egg emoji. What's that? Oh, okay. Okay, you might wonder why I put a little egg emoji. And that's because Bisect stands for binary search, and I find that binary search is quite easily explained using a bunch of eggs and a building. So let's say you have a building and you have a bunch of eggs, and someone tells you, I want to know the first floor that you go on where you drop an egg and it breaks. So you might start out on the first floor, drop an egg, you notice it doesn't break. So then you go to the second floor, drop an egg, doesn't break. And you just keep doing that until eventually it breaks. So you might get really lucky. You might get the desired result on the first floor, but you might get it on the 50th floor if the building is 50 floors. A more efficient way of doing this would be to start in the middle. So you start in the middle, it breaks. So you know that the first floor where it's going to break is between there and the bottom. So you go to the middle of that, and you notice that it doesn't break. So you go to the middle of that, and you notice that it does break. And now it takes a lot less time, probably, unless you're really lucky, to find the point that you were looking for. So you can imagine that if a building is, the higher a building gets, the bigger the chance it's going to take you ages to find the right point if you don't use binary search. So you can do the same with your history. You can do the same with your application. Let's say you have a button that shifted somewhere. And you realize that, like, okay, last week it wasn't like this. So something happened between last week and now. It's funny because I always use this example, and last week this actual thing happened. And I was like, yes, bisect. And my teammate was like, no, I know the exact commit where it happened because I was doing some JavaScript stuff, and we checked it out, and that's not the commit where it happened. I was like, let's do Git Bisect. So yeah, basically Git Bisect does the same as this. You take the commit where you know everything was still okay, and you take the commit where you know everything was bad, and it will check out somewhere in the middle. You can check stuff and mark it good or bad, and then it will check out in the middle again until you finally find out the place where stuff broke. So quick demo. This one's a little fast, so if I have to replay it, let me know. Also, if you want some practical practice, if you want some practice, just take any open source project, go back in time to whatever point in history, break a test, and then just run Git Bisect, run the tests on every point in the Git Bisect, and then you'll figure it out. So demo time. So I'm going to start the bisect by Git Bisect starts, and then I'm going to mark one commit as good. I'm going to take the last commit that I know is bad, and I'm going to go Git Bisect bad, that commit hash. Then it's going to check out the commit in the middle. I'm going to run my application. I'm going to see if it's good or bad. And then I'm going to mark it as such. And then it's going to check out the one in the middle again. That one's bad, so I'm going to mark that. And then you'll see there's 0 revisions left to test after this. So then you can go Git Bisect reset. And it'll just give you the commit hash that broke everything. So this can be quite, again, this is like 3 revisions, so it's not really worth it. But if you have a history that's like, you know it didn't break 80 commits ago, it's going to be much faster than manually checking every commit. So before we move on to question time, I had a lot of questions about this myself. Because again, I was quite skeptical because someone just came in and asked me to change my workflow, which I don't like to do. So just to remove some of the initial skepticism that I had, I'm gonna just pre-answer some questions that you might have because I had these same questions. So, but how do I call people out on mistakes? Because if you look at that first example where we amended, where you had the fixed bug, and then we rewrote history, then at that point you can't look at the PR and go like, oh, but actually you broke something else while you were fixing that commit. That's true because you rewrote history, so you won't be able to see that. But then you have to kind of ask yourself, like, what's the purpose of source control? Is it to point fingers, or is it to control your source? So it's kind of a mindset shift. I think the benefits of having atomic commits and rewriting much outweigh having the ability to look at different commits and say like, you changed something here that broke something. Like it's like taking two textbooks, like in school. You don't want the first edition. You're not going to take the first edition and the last edition, check all the pages, compare them, and say, they fixed a typo here. No, you're just going to take the last edition because you know it has all the typos fixed. It has all the most up-to-date information, so you don't really care about that old edition. It's the same with your application, I think. So the biggest one for me was like, how will this affect my flow? Because cleaning up all these commits, rebasing, it sounds like kind of a drag. It takes a much longer time than just merging. And sometimes, especially on like a Friday night or whatever, you just want to go home. So you have all these changes, you just want to commit everything, push it, bye. If I get sick on Monday, you'll have my changes on the origin. You can still do that. And I still do that every day, actually. So, because there's a difference between public and private branches. So your private branch is the one that you're working on yourself, but is not shared with anyone in the sense of like nobody else is working on that same branch. Everyone has their own branches. So if that branch is gross, history-wise, that's fine, as long as you make sure to clean it up before you merge anything into your public branches, which might be like master or a story branch that you've branched a task branch off of, or like the dev branch or whatever branch system you have public branches and private branches, and as long as everything's cleaned up before it goes in the public branches, you're good. And it's actually pretty easy to do that. If you take the situation that I was just talking about on the Friday night, you just want to commit all your changes for that day, make one big ass commit, and clean it up later. You can do that by resetting that commit and just taking the bits and pieces and putting them where they belong later. So let's look at a flow that I usually do on Monday morning. You'll have the massive commit for a day's work from Friday. I just reset that, git reset, head, tilde, and that just resets that entire commit. If you look at the git status, you'll see a bunch of changes. Now if I git log, I see that my last commit was about some handler, so I know that the handler file belongs in that. So I amend that one. Okay, what changes do we have left? We have bug fix, and two things that are relevant to feature X. So you know if you have a commit about feature X, they have to go there, and the other one needs to go into the bug fix commit. So I'm just going to add these, the feature X ones, and make a temporary commit out of those stage changes. And then I'm going to do the same with the bug fix. Just make a temporary commit with a non-pretty commit message. And then I'm going to go into my interactive rebase and clean all of that up. So you can reorder commits by just cutting them and pasting them somewhere else. So that's what we're going to do. We're going to cut that one, paste it after the commit that it belongs to. And then we're going to change pick for F for fix up. And it's just going to, if you write the file, it's just going to smush that into the correct commit where you placed it. And then if you go git log, you'll see that the massive commit for a day's work is gone, and it's all cleaned up into their the commits that they belong to. So that'll take you like maybe 30 seconds. That's it. So you don't have to constantly rebase, blah, blah, blah. As long as you clean up your shit, you're fine. Then, to come back to the force pushing thing, isn't force pushing scary? Because you will have to force push. So force pushing doesn't have to be scary if you protect your branches properly. And if you force push to your own private branch, that's not a big deal because that's your own private branch. If you're really scared of overwriting your own changes, you can always just really quickly check out a copy of your branch for later use until you don't need it anymore. But yeah, protecting the public branches is a big thing. Are we already out of time? Oh my God. Really quickly, can I just finish this sentence? Okay, jeez. Okay, it happened in my company that someone forgot to check out her own branch, then force pushed, and master wasn't protected, and everyone was like, well, now you overrode master. This sucks. So instead of blaming her, you could also just think, maybe we should have protected master, because people make mistakes and people get tired. So protect your branches, and then you'll be fine. And there's no time for questions. And here's a cheat sheet. Just come up to me or ask me on Twitter if you have any questions. Here's a cheat sheet with a recap of all the commands. So just look at this. Thank you.